Welcome to the Walton Pi. Today we're going to be talking about alternating series. So the comparison test and the limit comparison tests, those are only able to be used when we are dealing with series where every term in the series is strictly non-negative, meaning 0 or a positive number. An alternating series is a series in which the terms alternate between positive and negative values. So the alternating series test tells us that alternating series will converge if the following conditions all apply. So we need to have the series of the form the sum from k equals 1 to infinity of negative 1 to the k minus 1 times b sub k, where each b sub k is a positive or at least non-negative value. And we also need the b values to be decreasing, so each term is less than or equal to the term that came before it, and we need the limit of b sub n to go to 0. So we need the b values to always be positive, and we need them to be decreasing to 0. That's what we need for the alternating series to guarantee that the series from k equals 1 to infinity of negative 1 to the k minus 1 times b sub k, that will always converge if those conditions apply. So if we have an alternating series which does converge, there's also a really nice formula that gives us an upper bound on the error if we were to try and approximate the sum using only n terms of the series. So if our series is the sum from k equals 1 to infinity of negative 1 to the k minus 1 times b sub k, the error, so e sub n, is always less than or equal to b sub n plus 1. So we are adding and subtracting terms each time, but the amount we are adding and subtracting decreases each time, so we are never going to be able to get a sum that's bigger than just the next term that we are adding or subtracting. That is as far away as possible for us to be from our final end result. So that's why b sub n plus 1 is an upper bound on our error in calculating the sum using only the first n terms in the series. We also say that a series where the sum of a sub n is absolutely convergent if the series of the absolute value of a sub n is convergent. So it's absolutely convergent if the sum of the absolute values is convergent. A nice theorem involving absolute convergent series is that if a series is absolutely convergent, then the series itself is going to be convergent. So if we know that the sum of the absolute value of a sub n is convergent, then the sum of a sub n is also going to be convergent. We also will say that a series is conditionally convergent if the series a sub n is convergent while the series of the absolute value of a sub n is not convergent. That is what it means for a series to be conditionally convergent. I hope this video was helpful for you in understanding alternating series a little bit better. Please check out some of my other videos and like and subscribe if you haven't already so that I can continue to make these sorts of videos. Have a great rest of your day and good luck with the rest of your math.